In this video, we're looking at the sine rule. The sine rule helps us find the sides or the angles in non-right angled triangles. For the sine rule to work, we need to know 3 of the 4 either opposite angles or side lengths. So one example of this might be if you know the angle A and the corresponding side A, it's opposite, and you know angle B, but you don't know side length B, you know 3 of the 4 unknowns, so therefore you can use sine rule to help you solve that problem. Now we'll be looking at 2 variations of the sine rule. We have this one here, this is useful for finding sides, and then this variation of the same rule is useful for finding angles. So without further ado, let's look at this first problem here, find the value of x in the following. Our first step is to label our triangle. So A, B, and C, and then the opposite side, so A, this will be small a over here, small b, and small c. Now you can see here we're trying to find x, which is a side length, so we're going to be using one of these. Now we've got angle A and angle C that we care about. So see how we have 2 equations, 2 equal signs here. We're not going to be using the sine B over B or B over sine B part. So if you want to think about it, you can just go, okay, we're going to ignore this chunk and we're only going to be looking at this. So we write that in. A over sine A is equal to C over sine C. And then we substitute the values in accordingly. So A in this case is x. And angle A is 70 degrees. C is 8.2 over sine 60 degrees. Now we're going to use algebra to solve this firstly, and then we are going to apply, we're going to use our class pad to confirm. So we've got x divided by sine 70, we need to get x by itself. The opposite of dividing by sine 70 is multiplying by sine 70. What you do to one side, you do to the other. And so we get this, it's getting like a rather beastly equation here. Sine 60 degrees times by sine 70 degrees. So, let's just say your class pad's dead or you only have a scientific calculator. You can rearrange this using algebra and then just sub it or type it into your class pad. So I'm just going to clear all, and clearing all variables sometimes helps flush out your class pad if you're having a few troubles with your class pad. 8.2, and on the denominator, multiply by, and we get 8 and usually it's the 2 decimal places for side length, so let's go 8.90, and our units are centimetres. Okay, now we'll just let that load up. Now if you want to confirm this in your class pad using our solve function, make sure you just write CP solve, and I like to do this to start off. Okay, and then sub in x on, well it is, just kidding, 8.2 on sine 60, and solve. And we get the same answer there, so we're just confirming there, so 8.90. Okay, so we've found the value of x here. We're going to use the sine rule again to help us find x. Okay, so we've got this problem here, and we need to find the value of x. So what do we know? Well, let's label our triangle. A, B, C, small a, small c, small b. It looks like we don't care about b's this time, much like that first example, we only care about a's. Now, since we're finding an angle, we're going to use our finding angles formula here, so sine a over a, and so I'm going to do the same thing, and we don't care about the b's again. So I'm just going to cross that out, so it's going to be sine a over a, so let's write that in. Sine a over a is equal to sine c over c. We now sub in our values. We know a is going to be the x value over a, which is 7.1, is equal to, and then sine c, sine 120 degrees over c, which is 10.3. Now we are going to use algebra again to help us solve this, and then we'll confirm with our class pad, We're just simulating that event that you might lose your class pad or something happens on the day. So we want to get firstly sine x by itself, so let's times by 7.1 by both sides, and I'm not going to show the working for that. And we get this here, sine 120 on 10.3. And we do know that the opposite of sine is the inverse sine. So if we want to get x by itself, we take the inverse sine of both sides. So we're actually going to get that there. So let's have a look at this. You need to go and trig for this. And if we go and trig, you find inverse sine. And we get x is equal to 36.65 degrees. Now, we've got that answer there. The thing is, we've got this situation here where you go, well, could this be a supplementary? We know that sine of x here, we know that sine of x has two possible values, right? So we've got sine of x, in this case, we've got x is equal to 36.65 degrees. So we wonder, is there another value that will make the same thing? So this chunk here, the 7.1 sine 120 on 10.3, if we solve for this, we'll find that there's two times from 0 to 180 in which sine is equal to this value here. So there's not just 36.65. We know our supplementary rule is the other angle would be, and I'm going to call this x2, 180 degrees minus 36.65 because it's supplementary. So if I type this in the calculator and go take answer, we get this answer of is equal to 143.35 degrees. So there's actually two possible values for this one here. And which one would you say, are these both possible or not? Well, if we have a look at this, this is x here. It looks acute from the diagram. It hasn't set us to scale. But there is something here that's irking me. If this is 143 and this is 120, our triangle has gone far beyond the 180. So what we can do is we can just go, okay, we're going to ignore that value. It's a possible value, but we can see here it's impossible because of this 120 degrees. Now, the class pad down here, the working's been shown if you want to show it. And two answers pop out here. We've got the acute case and the obtuse case. So this is ambiguous as well, right? And only one answer could be, so we're just going to cross out that answer just to show us that the class pad can do that too. Okay, so the answer is 36.65 degrees. Now, I want you to pause the video and have a go at C and D applying the sine rule, and when you think you've got your answer, press play to confirm that you got your answer correct. Okay, so your turn to start now. So we're going to breeze through these. A, B, C. A, B, C. We don't have C's here, so we're just going to be using our angle formula with the A's and B's. And I'm just going to solve that in my class pad. When we're doing this, we just need to make sure that we put the given that. So if I just press enter right now, I get this nonsense here. So we need to say given that the angle is between 0 and 180 because this can't be anything more than 180 degrees. So we go into math 1 and math 3 and we find the given that. We go 0, given that x is greater than 0 and less than or equal to 180. Okay, and we get these two answers. And which one makes sense? Well, let's put them both down and cross out the one. If one doesn't make sense, I'm going to put the smallest one first. So I get 44.55 degrees or 135.45 degrees. And then let's just decide which one makes sense. So I've just written these down, they're just loading up. So this one here is 50 degrees, right? 50 plus 44 is 90, around 95, so that's possible. Here, 50 plus 135 is 180, over 180, therefore we can't have that one as well. So sometimes it might happen where you can have both, but in this case I'm going to cross that out because this is exceeding 180 degrees. Okay. The next one here, D, we're figuring out a side length. We label our triangle A, B, and C, and then go small b, small a, small c. Looks like yet again we're A's and C's, but A's and B's, but we're going to use the finding sides rule. A on sine A is equal to B on sine B. Sub in our values, X on sine 35 degrees is equal to 18 on sine 65 degrees. And I'm just going to do that again. So shift equals and then just start typing that in while this is all still loading. Equals, okay. Now this one we don't have to constrain because we're looking for a length this time. So we can just put this in and our calculator can deal with it. So X on, shift that, sine 35, close a bracket, 18 on sine 65. Enter, and we get X as being 11.39, always add your units, centimetres. Okay, so this is our video concluded here, looking at the sine rule, finding both angles and sides, and also looking at the ambiguous case, a good thing to note when using the sine rule.